In this activity, you're going to get a chance to practice all of those block diagram simplifications that we talked about. So this is quite a messy block diagram, and your goal is to step by step slowly identify chunks that you can simplify and do that, and then move to the next step until you get down to essentially our goal is to produce something that looks like R going into some big block produces Y. And so you're trying to figure out what the transfer function is of that one big block. There is a trick, something that we haven't exactly gone over, so you'll probably run into it after your first simplification. So you simplify one thing and then you'll get a little stuck. If you get to that point and like a hint, go ahead and move forward, and I'll do another pause in the solution after that hint. So in my solution, the first thing I'm identifying here is this feedback loop right here. That will give us the opportunity to simplify this G1, G3 simplification. In this case, this is not unit feedback, and so this G3 appears in the denominator as well. In this case, notice this plus right here. This is a positive feedback loop, so that's different than most of the ones that we'll consider. Usually we'll have negative feedback loop, like this one right here. But in positive feedback loop, that changes this sign, so that's a 1 minus G1, G3. So that is our new simplified combined positive feedback loop. And so that replaces that whole chunk. So now we need to do the next step, and the trick here is the fact that we can manipulate this diagram in another way that we haven't explicitly mentioned. And so to kind of motivate that, I'm going to give the name of the signal on this wire as X. And so that means that X goes into G2 and X also goes into G6. And that means that the signal on the other side will be G6 times X. If we were to change what's called the pickup point here, so the pickup point of this wire, if we were to instead put it over here and get rid of this wire, now what's going into this is now G2X. And so it would be on this wire is also G2X. But since we made that change, we need to make sure that this quantity has not changed. So the output of this block needs to still be G6X. So one way to do this is to divide what's inside the block by another transfer function. So we can put G2 in here. So we can replace that G6 when we move the pickup point here. We can replace that with G6 over G2. And now G2X is now the input, so that's G2X is now the input. And once I multiply through by G6 over G2, these two G2s cancel, and that produces G6X. So now that I've shown you that trick, go ahead and finish the rest of the activity. I'll give you another pause here, and then I'll continue on with my solution. So when we move that pickup point, we're going to, like I said, we're going to change this transfer function like this. What that allows us to do is now expose the fact that once we move that pickup point, now we can combine these two transfer functions, and that's just a multiplication. So that produces this new transfer function here with the G2 in the numerator. Now I have the opportunity to simplify this feedback that's happening right here. So when I do that, I get a particularly nasty set of fractions, but it's getting larger, but it's getting almost done. And now finally over here, this is actually a parallel. So it's important to realize which direction the arrows are going. And since these arrows are going essentially the same direction like this, that is not a feedback. because it's not cycling. So these are both shooting forward. And so the combination of these guys will give me one transfer function where those are added. And so now we have the transfer function on the left and the transfer function on the right, and they're just in series. And so we're just going to simplify that cascade. So that produces quite a long and lengthy transfer function. But this now is the transfer function. If we call that H, now there is a relationship. The reference goes into a block that's given by H and produces an output Y. And so that's the answer to this activity. One thing that we won't get into is multi-input, multi-output systems. In that case, you get the combination of transfer functions and matrices together in the same problem. Here we always focus on single input, single output cases, and so the order in which we multiply is not an issue. So that means that for transfer functions, we can swap the order of these and it doesn't matter. Here I've simply usually just used the index as the order that I'll use. So that's how you simplify that. You'll get some more practice on simplifying complex transfer functions and block diagrams like that.